let us study about static data members first, and then we will see member functions in C++. Right. Try to answer this, though this is in C programming. Let us see this question. Okay. Based on static variables. I am talking about static data members. I hope you are aware that data member and member function, anything which is declared in class, right? Class person, here you can have private colon int x, or you can have public colon void fun. Like this we will have some function inside class, right? So, the variables declared inside class are called data members, and functions which are declared in class are called member functions, right? This we have studied it already. So, what if those variables and functions are static in nature? What is this static? Okay, what is this? Why are we calling some certain type of variables as static and some functions as static? For this, let us understand the significance of static variables first. Static data members means, again, data members, this indicates that it is a variable of a class, it is a variable of a class. Okay. So, indirectly it is a static variable. See here, in main I am calling a function m, first time I am calling. So, it reaches, the control comes here. In this I have static int x equal to 5, in this it has static int x equal to 5. So, in memory x will be 5 and it is declared as static. It means there is some sign on, some special status is given to that particular variable. When I write x plus plus, you know that is a standalone statement. This x plus plus is a standalone statement. So, this x plus plus will give me, increment the value of this 5 to 6, and I am printing the value of x, that is 6. Okay. It will, the control will again go back to this main. From there again I have second m. From there I have second m, right. So, what is this m? Second time when I call the function m, again the control will come here, again it will come here. See, here again the same variable static int x equal to 5 is there. So, what do you think is the answer? Will it give me 6 6? What do you think? Answer will be 6 6 or any other different answer? Can you guess the answer here? Will this again make the x value to 5? Will this statement will be assign the x value to 5 again or not? Okay, you say it will be assigned to 5, right. So, when you declare a variable as static, okay, so first time what happened? Let us again say from the beginning. First time when I called m one time, first time it came here, this was there, so it gave 5 here, x plus plus, it make it 6, and I have using cout or printf, I am printing value of x. So, in the output I am getting 6. Second time there is again m. So, when I call the function m second time, it is encountering a statement static int x equal to 5, this will not be executed. Static variable will be assigned values only once, they will be initialized values only once. Okay. So, compiler will skip this statement because already in memory there is a static variable x created. So, this statement will not be considered second time. Static variable can be initialized only once. Okay. So, it will directly come to x plus plus. What is the current value of x? 6. It will increment and become 7, and see out the value of x, that is 7. So, answer here will be 6 and 7. This is the significance of static variable. Okay. Static variable cannot be re-initialized. Initialization of a value will happen only once. Okay. So, with this idea we will try to go and see how does these static variables inside a class called as static data members function. Okay. How do they work? Let us see that. I hope it is clear. This is what the logic of static. Okay. There is nothing much. Okay. I will talk this in terms of class and object. Let us see one example. Struct student. In this I will create int a, maybe I will create char ch, that is it. Okay. I have a struct student, right. I have a structure with the name student, I have two variables a and b. I will be creating variables to the structure, right? From main, you can create variables to the structure by writing like this: struct student s1 comma s2. What are these s1 s2? S1 s2 are the variables of the structure, or in terms of C++, if I say s1 s2 are the objects of the class student. Okay, and the very important point, I will repeat once again: unless until you create variables, or objects, memory will not be allocated. Why is that said? Please try to understand this one very important concept of static data members or static functions, member functions. See, when you create variables like this s1, s2, you can write s1 dot a no as 10. You can also write s2 dot a as something like this. See, this variable is fixed. This variable a is fixed. So s1 dot a I am giving 10, s2 dot a I am giving 20. It means for these two objects s1, s2, for these two variables s1, s2, separate memory is allocated. Okay, separate memory is allocated. It means for see what is the size? This is 4 bytes, this is 1 byte. For s1, separate 5 bytes is reserved for a and ch. For s2 also separate memory is reserved, that is for a and ch. If I create another variable s3, separate memory will be reserved for a and ch. Okay, so same thing, this is how structure works. When you create variables, memory is allocated like this: 5 bytes, 5 bytes, 5 bytes. Okay, separate see, though the variable name is a, but a has a different here, a has a different memory here, a has a different memory here. How do we access this a? You will write s1 dot a, s1 dot b or ch, s2 dot a, s3 dot a. Using dot operator, you can access the variables. My point here is that memory is allocated separately for separate variables. Let us see the same in class. When I have a class, maybe class new, some simple one, I am taking public variables int x1 comma x2. I am taking another function void add, something like this I am taking here. So I am writing here return x1 plus x2. Okay, this is my class, very simple. Class new, I have a public, all are public only, public variables int x1 x2, and a void add function exists which will return x1 plus x2. Okay, it will return x1 plus x2. Now generally what we do, you will go to main, and from main you will create objects. How? New space o1. When you create an object o1, what happens? This o1 can access x equal to 10, o1 that is x1, o1 dot x2 equal to 20. Okay, so using object o1, I am able to access the public variables, public data members, that is x1, x2 like this. And I can also write o1 dot add. I can call this function o1 dot add. Okay, this, and you can print, you can print the value. Okay, you can do the operation accordingly. So the point here is to tell that once you create an object o1, a copy of x1 is created, a copy of x2 is created, and this address is also, again it is also a copy of this function is created. The privilege is given to o1. The privilege is given to o1. Suppose if I create another variable here or another object o2, if I create another object o2 here, again same I can do, o2 dot x1 equal to 35, o2 dot x2 equal to 45. I can do like this. It means for object o1 separate memory is allocated, for object o2 separate memory is allocated. That is why when I print o2 dot x1, I can say this value. When I print o1 dot x1, I can print this value. Okay, again it means whenever you are creating, here the point here is that whenever you are creating objects o1, o2, o3 so on, all these variables and function inside the class, all the variables and function inside the class, for each of them a separate memory is created. A separate memory is created, for memory is allocated for o1 and o2. It means copy of this x1, x2 is created for o1, copy of x1, x2 is created for o2. If you create 10 objects, each 10 object will have separate memory allocation. Okay, this is how generally it happens. Now come to the actual point, static data member, or we will see static data member first. Okay, when you declare, same example, let us see here, class new, I have private, or let us make everything public and just see a simple example. Inside class new, I have public, I have int x1, I have static int x2. Okay, one variable is normal, other variable is static int x2, right. So, then I have some function void add, same thing, okay, same logic again, right. Now, when you create an object, okay, from main, when we create an object new o1 comma o2, so o1 dot x1 equal to 10, o1 dot x1 equal to 10. Here what is happening here, o1 dot x1 is pointing to separate memory, o2 dot x1, o2 dot x1 is also, if this is also 10, but both of them are different, they have different memory allocations, both of them point to different memory locations. Whereas when you have x2 as static, all the objects o1, o2, o3, anything, they will have a fixed address, x2 will be fixed always, that is 100 for example, address is 1000, it contains some value 20 for example, because it is static variable x2 20. So, in this case, if o1 is pointing, if I write o1 dot x2, it will point to this location only, if I write o2 dot x2, it will also point to same location only. Memory is not shared here, they all point to this only element here. Whereas o1 x1, separate block is created, this is for x1, it has some value 10. O2 dot x1, again separate memory block is created, this is 10, this is x2, O2 object, right. So, using static data members can be accessed only to one point, static data members can be point to only one variable, whereas the memory allocation is fixed for them. That is why always this value, it will not change 20. Okay, I hope it is clear. I hope you got little idea about this static data member. Okay, again I will repeat what is happening here in static data member. All the objects of the class new has some objects o1, o2, o3, so on. Everyone will have a different memory allocation. If the class contains variables like x1, x2 and x3 as public, normal variables int, and there exists a static variable x4, static int x4 if it exists, then for o1 when you create this object o1, only this much memory will be allocated for x1, for x2, x3. Okay, what about x4? x4 will be common, it will be here. Okay, so it is virtually connected to this x4. Now, this is for object o1. For another object o2, let us take another object o2, same thing, x1, x2, x3. What about x4 of this object o2? This will also point to the same memory location. Okay, though in these normal variables have some value 5, 6, 7, 8, 9, 10 like this, but once this value is assigned as o1 dot, we cannot do it using object, but just telling example, if someone assigns this o1 dot x4 equal to 15, okay, then if you write o2 dot x5, it will not change, it will point x4, it will point to only this location only. Okay, for all the objects memory allocation is repeated, x1, x2, x3 here, x1, x2, x3 here. If there is object o3, again x1, x2, x3 here. But the static data member will have a common shared memory, it will not change, it will not recreate. That is why I say static variables will not be reinitialized, its value cannot change with the variable, with the object, whether it is object o1 or o2 or o3 or anything, this remains a shared memory location like this. This will be accessed by every object, but all of them, see where is this x1 pointing to? Where is this x1 pointing to? This x1. O1 dot x1 is pointing to this location only. O2 dot x1 will point to this location. O3 dot x1 will point to this location. Every variable has different, though the variable name is x1, based on the object it has different memory allocation, whereas O1 dot x4 will point to this only, O2 dot x4 also will point to this location only, and O3 dot x4 will also point to this location only. So, its location is fixed, that is why you cannot reinitialize the value. Okay, this is about static data members in C++, right. Let us see little different information about the static data members. So, static data members are class members that are declared using static keyword. What is the advantage of this? What are the special characteristics this has? Only one copy of that member is created. Just now we have seen only one copy of that member is created for the entire class and is shared by all the objects of the class. It is shared by all the objects of the class, no matter how many objects are created. There can be 100 variables, 100 objects, still that static variable will be shared only. Everybody will point to that location only. Okay. It is initialized before any object of the class is created. This is one very important point. It is initialized before any object is created. It means indirectly it says that. Now, to explain this point, again I will go back little about class concept here. I have class, some new bracket, I have some public variables int x1, x2, x3 and nothing else in that. Let us assume that main. What you do? You have to create an object first. So, you will write new O1, you will write like this, right. You after creating object only, you are able to access x1, x2, x3. So, you can write O1 dot x1 equal to 10, O1 dot x2 equal to 20, like this you can do. You are able to access the members of a class only by using object. Okay. You are able to access the members of this class new only by creating object O1. Whereas, for static data members or static variables, object creation is not required. Without creating an object, you can access the static data members. Okay. Before any object, without the help of an object, you can access the static data members. We will see how it happens. Syntax is very simple. Inside the class, just use static. Okay. We will see small program. Okay. We will see this program. Then we will go back and understand this theory part. Okay. See here, namespace IOStream class A public. See, I declared a variable static int x. I declared a variable static int x. Then I have one more function A and there is some output in that. Simple, ignore. Okay, there is some output in that. Printf statement is there, some cout statement. See, how do we assign values to static variables? Static data members of a class can be assigned value outside the class only. See, class A, I have declared a variable static int x. Okay. Generally what we do when you create a variable inside a class, for that what you have to do, in main you have to go and create an object. From main you have to create an object A, comma B, like these two objects you have to create. Using this object only you can assign values. Like this you can play, right. Whereas for static data members, you can assign values outside class without using the help of an object. How? See, outside class I wrote it like this, using scope resolution operator, int the class name, colon the variable name and what value you want to assign. So, static data members are values are initialized or assigned to static data members outside class, and to create outside class, it does not mean through object, it need not be created using object. Okay. Without you creating an object also, you can access the static data member. How? Using this scope resolution operator. This is an example, you see, int A colon that is scope resolution operator x equal to 2. A is the class name. So, you have to give int the class name scope resolution operator and the variable name equal to the value this way. So, this is the data type, this is the name of the class, then static scope resolution operator, variable name and its value. This has to be done outside main and outside class. It has to be done outside main and outside class. For this, you need not create an object without, see, and this static member of variable x can be accessed in this function A. That is not a problem. See, accessing the static data member, that is class name : x. When I do this, I will get the answer as 2. Okay. How do we access the static data members of a class? You can access it using scope resolution operator. That is what we were studying when we went back and saw about the usage of scope resolution operator. To access the static variables of a class, we use scope resolution operator. Now, see this example to understand much better about the static variables. See, there is a class test. I have static int x, which is public. Again, I have which is private. Default is private in C++. Then I have public static int y. I have some function void func, and there are some statement in this. See, how did I assign the values to the static variables? Like this. What are these? X and y are static data members of a class. They can be initialized values outside class using scope resolution operator like this. Int class name, scope resolution operator, : and x equal to 1, again int test : y equal to 2. This way, scope resolution operator is used to assign values to static variables or static data members of a class. Okay. Other things are normal. Using the class name, you can print those values. See, using class name, I can print those values. Object is not required to access static data members. To access static data members, object creation is not required. It can be done directly using the scope resolution operator. Let us go and study little about this thing. See, how do you assign? Static members are only declared in the class. They are only declared in the class. Okay. To access the static data member of any class, we have to define it first. How do we define it? Like this. Okay. We have to design this. We have to define it like this. How? You have to write data type, the class name, scope resolution operator, the variable name and some value assigned to it. This way you have to do. Where you have to do is, you have to do this outside class and outside main. Okay. So, this is how we assign values to static data members. How do we access that? First way to access is using scope resolution operator. That is what we have seen just now. See here, how am I accessing the variable? I want to print the value of this x. How am I doing it? Using class name, scope resolution operator, variable name. Using this logic, I can print the value. That is one way. And the second way, using object. Normally using object. I say object creation is not required, but if you create an object also you can access it, not a problem. So, using the object of that class, you can access that variable directly, normal case. But it is to tell you that without creating an object also, some data members of a class can be accessed, that is static data member. Okay. So, this is an example to understand about static data members. Let us see some queries or some important points of this static data members. Okay. See, can static data members be private? Yes, they can be private. Here in this I wrote public, you can put it as private also. Same rules are applicable. When you create some variable as private, what do I have to do? When you create some variable as private in C++ in a class, that variables can be accessed only in the functions inside the class, but not outside. Same rule will be applicable here also. So, you can declare it as private also. Okay. Next, can we initialize static data member within the class definition? No, we cannot initialize. We have to do it outside only like this. You cannot do it here. You can do it outside the class only, not inside the class. Third, can we inherit static data members? Okay, we are yet to study inheritance, but they cannot be inherited. Static data members cannot be inherited in their child classes. And the last one, can we have static member functions in a class? Yes, we can have static member functions in a class. That is what our next concept is about static member functions. Okay. So, this is about static data members, right. So, we got an idea that static data members are having a shared copy. All the objects will share only one copy of that particular variable, which is declared as a static. That is one very important point. And the second important point is, without even creating an object, you can assign some value to the static variable, and also you can access it. Accessing means printing, using, doing some operation on that. That can be done, though static data member is a variable of a class, and we know that any variable or function of a class should be accessed using object, but static data members need not be accessed using the objects. Without creating an object, I can play with that static data member. Okay. So, this is about static data members or static variables inside a class. Okay. Right.